Hi, welcome back. We're going to take a look at a few more examples of our arc trigs. So for the first, we're going to take a look at this is number 6. Okay, we were looking for the antiderivative of 0 to root 3 over 2, and we are going to integrate dx over 1 plus 4x squared. Now you might recognize this as your arc tangent, which we should. This becomes 1 over a arc tangent u over a. So a is pretty easy; it's just 1. My u is this 2x, so my du is of course 2 dx. Give me dx is du over 2. This is the most important part because it's telling me I have to divide my final answer by 2. Now, some things that people do mess up on, sometimes they tend to flip this. they'll put like 1 over 2x here and 1 over 2x here. They tend to flip them. And the easy way to remember that down here, the bottom here, better be a number. Okay? All right. So when I write out my arc tangent, this becomes 1 over 1. Whoops, I messed up already. 1 over 1 arc tangent u over a, which is 1. And don't forget, we got to multiply that by 1/2. Okay? So this really becomes 1/2 arc tangent of 2x over 1. And you can just write that as 2. So we're now going to evaluate this from 0 to root 3 over 2. I'm going to factor out that 1/2, and that's going to become the arc tangent of root 3 minus the arc tangent of 0. Now don't forget, right? F of b minus f of a, where b is root 3 over 2, a is 0. I do expect you to know some trig values. So the arc tangent of root 3 is pi over 3, and the arc tangent of 0, well, that's just 0, and what we're left with is pi over 6. And there is our answer for number 3 right there, or number 6, sorry. Now number 7 is another goodie, oldie but a goodie, so we're taking a look here, moving along. It was giving us 2x squared over x squared plus 4 dx. Now this looks like it's going to be my arc tangent, and it is. There's a couple ways we can do this one, but I'm going to divide because the power is the same. I treat this like a big on top. I'm just going to divide. I'm going to take that 2x squared and divide it by x squared plus 4. You would get this the same way if I were to add 4 and then subtract 4. You'll get the same answer in the end. So this becomes, if I divide it, I'm going to multiply by 2. I get 2x squared plus 8. I have to subtract, and I just get minus 8. So we get minus 8 over x squared plus 4. And that's going to allow me to rewrite our integral as 2 minus 8 over x squared plus 4 dx. So when I do this one, of course this one's pretty simple to do. That just becomes 2x. Here is my arc tangent. So if that's my arc tangent, my u is x, so my du is dx. I'm not dividing by anything. See up here, my du wasn't just dx. My derivative u was not just dx. It was 2, so I divide by 2. Here, it's just dx, it's just 1. I'm dividing by 1, basically. And a is 2. Well, same rule up here. We're going to get 1 over a, so we get, don't forget your 8 though, minus 8 times 1 over a, which is 2, times the arc tangent of u over a, x over 2 plus c1. And if you reduce that, you would of course get 2x minus 8. Whoop, that's what we were looking for. Just don't tell my students I did that. 2x minus 4 arc tangent x over 2 plus c1. Which is why I always never really simplify, just leave them alone. It makes it a little easier for us. Okay, let's take a look at one of the hardest ones that we could ever give you. Ready here? All right, this is another integration by partial fractions. Okay, this is number 9 on the worksheet if you're following along with my homework, but if you're just following along just for the fun of it, this is a really good one. From root 3 to 3, 3x squared minus x plus 9 over x times x squared plus 9 dx. Now, this is already factored for us, so this is already factored. So this is our partial fractions. So when I do my partial fraction part, we're going to get this 3x squared minus x plus 9 over x times x squared plus 9. There are two factors, so I get two fractions. Here we get x. I'm going to put an a over there because that's linear. That has to be a constant. And for the other one, we got this x squared plus 9. So this has to be a linear function, so I'm going to write down bx plus c right there. And my common denominator is just x times x squared plus 9. And that's going to give us 3x squared minus x plus 9 equals a times x squared plus 9 plus bx plus c times x. Okay, using using the Heaviside method, we are going to find our zeros. Now you're going to find out we only have one zero in this case, and that is just literally this x is 0. So if I let x be 0, that's going to give me 0 minus 0 plus 9 equals 9a plus 0. So we know that a is just going to be 1. Now, to find a, b, and c, this is our special algebraic trick that we're going to do here. We have two options. Option 1, I could just pick any of the two x values. I could pick negative 1 and positive 1, I already used 0, or any two x values to find b and c. But there's another way. We can just plug in a here. So if I do that, we're going to get 3x squared minus x plus 9 equals a is 1 times x squared plus 9 plus this bx plus c times x. Now, I'm just going to bring this all over. I'm just going to bring it all over, and that's going to give us 2x squared minus x, the 9s are going to cancel, equal to bx plus c times x. Now, I'm just going to leave that alone. Remember, these are the same fractions. If they're exact, they are the same. These are the same answers. These are the same. That's what the equal sign means. So in other words, they have to have the same factors. So out of this one, if I factor out an x, I'm going to get 2x minus 1 equals this bx plus c times x. Well, they already have these x's the same. What does it mean about these two? Oh yeah, those are also going to be the same. So I can now say b is 2, c is negative 1. Now, we haven't even done the calculus yet. That's just using the Heaviside method. Now we go back up here, we're going to rewrite our integral. So when I rewrite my integral, remember we said a is 1, so we get 1 over x plus bx plus c, so we 2x minus 1, 2x minus 1 over x squared plus 9 dx. All right, now we're ready to integrate. Or are we? Oh, not yet. Because notice, if I got rid of that 1, I could use substitution. But if I get rid of the 2x, this is just my arctangent. So here we are going to, again, split our fraction. And that's going to become 1 over x plus 2x over x squared plus 9 minus 1 over x squared plus 9 dx. And let's see how fast we can go with this one. Are you ready? For the first one, that's easy. That's just natural log of x plus, here, my u is 2x. Sorry, my du, if I take the derivative at the bottom, just 2x dx. dx is du over 2x. Those are going to cancel, and we're left with the just 1 over u, because remember all of this just becomes u, natural log of x squared plus 9, whoops, absolute value. And remember, we already said that this is my arctangent, so u is x, du is dx, a is 3. So arctangent, remember, is 1 over a, u over a over here. So minus 1 over 3 times the arctangent u over a, so x over 3. And we're still not done yet. I mean, this is my antiderivative, but remember, they wanted me to evaluate from root 3 to 3. And the hits just keep on coming. All right, so what are we going to do? Let's do f of 3, big parenthesis, minus f of root 3. Big parenthesis, plug in the 3. We get natural log of 3 plus natural log of, what's that, 9 plus 9, so that's what, 18? Minus 1/3, this becomes the arctangent of 1. Minus, plug in the root 3, we get natural log root 3 plus natural log, if I plug root 3 in here, I get 3 plus 12, which is 3 plus 9, which is 12, minus 1/3 the arc. Oh, ran out of room here. Should use a bigger parenthesis. Arctangent root 3 over 3. Ugh. It still looks like we're done, but I can still go a little bit further because I know the arctangent of 1 is pi over 4. So I can write this as natural log root 3 plus natural log 18 times, minus 1/3 times pi over 4 minus the natural log of root 3 plus the natural log of 12 minus 1/3 and the natural log of pi over, remember this is the arctangent root 3 over 3, which is pi over 6. We should always reduce our trig values if we can. Alright, that's as ugly as they come. If you see something like that, you can do that one, you can do anything. You're golden. Alright, I'll see you guys in the next video. We'll work a couple more. Okay, see you soon.